Students, today we are going to start with topic number 3.4, Instantaneous Velocity and Speed. In our last lecture, we have studied about average velocity. Now we know that for average velocity, the time interval is large. So if the time interval is large, then the velocity obtained is average velocity. So here it is given that if an object moves over a given time interval means that time is little large, we get average velocity. But if we take that time interval, that is delta t, very small, if we take that time interval very small, nearly equal to 0, so here this delta t tends to 0 means delta t is nearly equal to 0. It is not 0 but close to 0. That means very small time interval. So in that case, the velocity obtained is instantaneous velocity. For example, if I am moving from Ahmedabad to Baroda, so suppose from Ahmedabad to Baroda, if I am reaching in 1 hour and let it is 100 kilometer away from the Ahmedabad, then what is my speed or velocity in this case? So in this case I can say that velocity v is equal to distance, which is 100 kilometer. So I'll write here distance upon time. Time is 1 hour, so upon 1, that is equal to 100 kilometer per hour. So this velocity is actually average velocity, because in between from point A to B, many times the velocity have changed. Sometimes due to traffic the velocity was decreased. When the road was very fine like a highway, at that time the velocity increased. And so there are different velocities, but here I am considering entire time from 0 to 1 hour, and for that the distance is also considered from A to B. So that is nothing but average. What is the velocity in between at different points, that is not considered. But if we are going to consider the instantaneous velocity, means the velocity at that time means suppose during the motion, if you are driving a vehicle, at some instant if you are observing to the speedometer, so whatever the speedometer shows the velocity, that is instantaneous. Suppose whenever you are looking at the speedometer, it shows 60, so what is that 60? It is an instantaneous velocity. Then if you are decreasing the velocity and you are watching to the speedometer once again, if it shows 40, that means that 40 is instantaneous velocity, because the time interval for that observation is very small. So students, I hope you understood what is instantaneous velocity, and to find this instantaneous velocity, time interval should be very small. So now instantaneous velocity, or simply we can say velocity, means it is instantaneous only. So instantaneous velocity v is limit delta t tends to 0. Students, remember, if I simply write delta x upon delta t, then that gives me average velocity. But what we are doing here, for this average velocity, we are limiting this time. What we are doing, we are limiting this time nearly equal to 0. That means this large difference delta is made very small. Delta means little large difference, but here this large difference of time is made nearly equal to 0. And so when this time is limited to very small, at that time the velocity obtained is instantaneous velocity. So limit delta t tends to 0, delta x upon delta t gives you dx upon dt. So instantaneous velocity v is equal to dx upon dt. Now students, this term dx upon dt is new for you. If I say from here to here the distance is x, that is from this points p to q, the distance is suppose x, but if I'll take only this much distance on this line, then I can say this small distance is dx. It is very small, so we can denote this distance as dx, means very small distance. Similarly, for a small time we can write it as dt. So what we are doing here, we are differentiating. What we are differentiating, we are differentiating this x with respect to time. Remember students, once again, what we are doing, we are differentiating this x, that is distance, with respect to time. So we can read this term as dx upon dt also, or you can read it as d by dt of x, means differentiation of x with respect to time, or you can read it as time derivative of x. Once again students, what we can read, we can read it as time derivative of x, and here this x is a function of, this x is a function of time. What do you mean by function of? If I say x is a function of time, means this x changes with time. X is a function of time means x changes with respect to time. So I hope students you are clear with this new concept, and if it is not clear, then also it will become clear to you as this topic will go on. So don't worry at present. Now see here, I have written this different way of reading this term, how we can read it as. So I have written this here also. Now we know that path length is always greater than equal to displacement. Similarly, speed, which is always positive, and it is greater than or equal to velocity. And velocity can be positive, negative, or 0. But here these two lines shows that is magnitude of velocity. Now about the graph of position versus time, that is xt graph for instantaneous velocity. Now students, you must remember the graphs which we have studied earlier. That graphs were for uniform motion, and we know that if the motion is uniform, then the graph will be straight lines. You can see here once again, you can see here the graph is straight line here. The graph is of position time. So here the motion is uniform motion, and if the graph is upward slope, then it is always positive and its slope will give you the velocity. Again, second graph was downward slope. Again, it is a straight line only, but if you find the slope, you will get negative value, and so the velocity will be negative. Then third graph we have seen about, again straight line only, but it is horizontal. In that case, the velocity is uniform, but how much the velocity? Velocity will be 0 because it is horizontal line and it does not have any slope. So velocity will be 0. And also we have seen this graph. If the graph is not a straight line, if it is curved line, then that is called non-uniform motion. Means velocity goes on changing. So at any two time intervals, if you'll find, then this velocity will be different. If you'll find from 3 to 5 seconds, then that velocity will be different. So velocities go on changing if the graph is not a straight line. So now in this type of case, when the velocity changes, how can we find the velocity at any particular time? That is instantaneous velocity. So students, let us understand this. Here you can see the graph is given for position and time. If we are measuring the velocity from time 6 second to time 13 second, so you can see here this time is large, and at 6 second we can get this point on this slope or a curved line. On a curved line we can get this point. At this time, that is at 13 second, we get this point. And so if we find the velocity, then we have to stretch a straight line from point P2 to point P1, and for this much difference of time, whatever the velocity we are getting from the slope of this line P2 P1, that will give you average velocity because the time interval is large. Now if we'll reduce the time interval, let us consider from 8 second to 12 second. So on this curved path, with respect to this 8 second, the point is Q1, and with respect to this 12th second, the point is Q2. Once again, if we'll draw a straight line from Q1 to Q2, and if we'll obtain the slope, then once again what we'll get? We will get average velocity. Why? Because once again still the time interval is large. Now if we want to find the instantaneous velocity at exactly 10th second, means at 10th second what does the speedometer shows at that particular time? So if we want to find that velocity at 10th second, then we can say that it is an instantaneous velocity, and for that what we will do, we will simply take a point P on this curved path, on this curved graph, and so at this point if we'll draw a tangent, you can see this is a tangent. You have studied in 10th standard that for any circle, if you take any point on that, then you can get a tangent to that point of a circle. So here also it is a straight line, and so if we'll draw a tangent at point P to this curved line, then that is a straight line, because this tangent is a straight line at this point. And so if we'll obtain now the slope of this tangent, then that will give us instantaneous velocity at 10th second. So students, to obtain the velocity at this 10th second, what we did first, we took this two time interval between points P and Q. Then what we did, we reduced the time interval, that is this two times, but still the time was large, so that was also not instantaneous. And then after reducing, we have reduced the time for very small, that is only this much difference, that is nearly equal to 10 second only. Very small difference we have taken, and so for that difference we got the velocity that gave us the instantaneous velocity. I hope you understood this, the topic of instantaneous velocity, even from the graph also. So now from this graph, the slope of P1 P2 gives us average velocity. It is because the time interval is from 6th second to 13th second. Then we reduced the time interval and we got the line segment Q1 Q2 for 8th second to 12th second. You can see that this difference is more and this difference is less. So when the difference is reduced, what happens? The velocity which is obtained will be near to the instantaneous. But still, if we'll go on reducing the time interval again and again and again, and if the time interval is very small, then at that time the velocity which is obtained will be very close to the instantaneous velocity. Now students, before we move to our examples, I would advise you to go through the textbook. You should have a habit of reading textbook. Read each and every line. Try to understand it. Now before we move to our next example, example number 3.2, we should first learn the formula related to derivatives, or we can say differentiation, because to find the instantaneous velocity we should know these relations. Now students, here the first formula related to derivative is d by dx of c. Now what is c here? It is any number, any constant. So differentiation of any constant is always 0. Now what do you mean by constant? Those things which do not change with time, that things are called constants, which remains same, that are constants. Any number is a constant. For example, if I say I want to find d by dx of 5, then 5 is a number, and so its differentiation will be 0. Next is d by dx of x raised to n. Here this x is a function. See here, you can see it is d by dx. So it is differentiation with respect to x. And so here the function is given x. And so if this type of differentiation is there, then you should write this as n x raised to n minus 1. Means whatever power is here, that is in multiple here, that is to be multiplied, and then x raised to whatever the power is here, that is reduced by 1, that is n x raised to n minus 1. Let us take one example so that you can understand it more. Suppose if I say I want to find d by dx of x raised to 3, then its differentiation, whose differentiation? X cube. Differentiation of x cube is this 3 will be in multiple, then x raised to whatever the power is here, that is reduced by 1. So 3 minus 1, that is 2. So 3x square is the answer. Means differentiation of x cube is 3x square. Next is combination. Combination of what? Combination of constant, and there is also function of x. So d by dx of c into x raised to n. Now students, if there is only c, then its differentiation is 0, that we have studied. But here this c is with this function x, and so in that case it will not be 0. So differentiation of this is equal to constant is to be taken out. So we have taken out constant, and now what remained if this c is taken out? Remained is d by dx of simply x raised to n, and we know that differentiation of x raised to n is n x n minus 1, the one which is done earlier. Let us take one example so that you can understand it better. Suppose if I want to find d by dx of 7 x raised to 2. So what is its differentiation? 7 is a number, so I have taken it out. So what is remained inside? X square. So I can say that 7 is taken out, and so I have to simply differentiate that x square. So d by dx of x square. Student, 7 is taken out, and now differentiation of x square. So what will be the result? The result will be 7 as it is. What is differentiation of this x square? So 2 will be in multiple, and x raised to, what we have to do? We have to reduce power by 1. So 2 minus 1 is 1. So it is 7 into 2x. Finally you will get 7 to the 14. So 14x. So result is 14x. I hope you understood. Still not? Then let us take one more example. Again, suppose I want to find d by dx of minus 5 x raised to minus 3. See, now I have taken this constant also negative and power also negative. So now what is the differentiation? So as I said, the constant is taken out. So I have taken out this minus 5. Now what we have to do? We have to simply differentiate this. And what is differentiation of x raised to minus 3? So what we are doing? This minus 3 is to be taken in a multiple. So minus 3 x raised to, what we have to do for the power? Already minus 3 is there, and what we are doing, we are reducing the power by 1. So already it was minus 3, and again we are reducing it by minus 1. So here in this case the power will be minus 3 and minus 1, so it will be minus 4. And so what will be the final answer? Look at this, minus into minus plus, and 5 3s are 15. So it is 15 x raised to minus 4. So I hope you understood. Now let us move to this next. Now if there is a logarithmic function, this ln means it is a logarithmic function. So differentiation of any logarithmic function will be this type, that is d by dx of ln x is 1 by x. Students, remember this. Directly we have to write 1 by x. Similarly, exponential function, very easy. D by dx of e raised to x will be same, e raised to x only. I hope you understood this. Still, let us give me example for this last one. If it is d by dx of 3 e raised to 2. Now what will be the answer? 3 is a constant, so taken out, and now it is e raised to 2. Now see here, this is not x, it is e. If it is x, then we use that previous relation, but here it is exponent e, and it will remain same, so it is e raised to 2 only. So 3e square. Now students, there are some more rules, but I'll not explain you at present. Whenever their use will come in any example, then I'll explain you these rules. At present it is not required. So now let us move to example number 3.2. Students, get your textbook, open it, and just go to the statement. You will find that given this equation of x, means it is equation of position, given that x is equal to a plus b t square. Here what is a and b? They are constants. Remember students, these are constants and their values are given. A is equal to 8.5 meter and b is equal to 2.5 meter per second square. So if we'll put these values of a and b in this equation will become x is equal to 8.5, which is value of a, 2.5 t square. Here this 2.5 is value of b. Let us give this equation number 1. Now what we want to find? So here we want to find velocity at time t is equal to 0 second and at time t is equal to 2 second. Now see students, here this velocity will be instantaneous velocity because we want to find at this second only. No difference is given. Also, we want to find velocity at this much second, that is at 2 second. No difference is given. But in second, you can see it is average velocity. And why it is average? Because we want to find this velocity from time interval t is equal to 2 second to t is equal to 4 second. So here it is a time interval. There are two times are given from this time to this time, and here only single time is given. So for this and for this it will be instantaneous, and from this time to this time, that is average. So now let us first find for velocity at time t is equal to 0 second. So as it is instantaneous, and to find instantaneous velocity, we have to differentiate the given x. Equation 1 gives x. It is equation of x. And differentiation of x with respect to time gives us velocity. Because here this dx is a small difference of distance and this dt is a small difference of time. And so distance upon time is velocity, but here this both are very small, and so it is instantaneous. So now d by dt of x, we have kept the value of x here. Now simple differentiation is there. We have to differentiate this also, plus we have to differentiate this also. That is, here there are two terms, so differentiation of first term plus differentiation of second term. Now here first we will differentiate the first term. So d by dt of 8.5. But what is 8.5? It is constant. And what is differentiation of any constant? It is 0. So differentiation of this 8.5 is 0. Now we will differentiate 2.5 t square. Now differentiation of this 2.5 t square will be 2.5 is constant, so we'll take it out as I told earlier. And then what we'll do? T square. For this t square, 2 is in multiple and t raised to what will be power? We know that 1 power is reduced. So 2 minus 1 is 1. So finally what we'll get? 2.5 into 2 is 5. And t raised to 1 means it is simply t only. So we got v is equal to 5t. This is instantaneous velocity. Now we want this instantaneous velocity 1 for time t is equal to 0 second. You can see here for 0 second also we want to find, and for 2 seconds. So first what we will do? We will put t is equal to 0 in this equation. So 5 into 0 is 0. So we'll get the instantaneous velocity at time t is equal to 0 as 0 only. Then we also want to find the instantaneous velocity at time t is equal to 2 seconds. So already we have the formula for instantaneous velocity, which we have obtained by differentiating the equation of position from this. So now we will put simply t is equal to 2, and 5 2s are 10. So our answer is 10. So this is the instantaneous velocity at time t is equal to 2 seconds. And whenever you write your final answer, unit should be mentioned, meter per second. Why? It is because here this x is in meter. Just go through the statement. This x position is given in meter and the time they are given in second. You can see here the time is given in second, and so unit is meter per second. Now second part, you can see here 2 time difference are given. So what we will do here, in that case no differentiation is used. Remember, because it is an average velocity, so delta x upon delta t, we have the formula for average velocity v. Now what is delta x? Final position minus initial position. What is delta t? Final time minus initial time. Now students, how we can find this x1, x2, that I'll show you. We know that the final time here is given, initial time is also given, but these positions, that is initial position and final position, it is not given. So that we will obtain. You can see here the values for this initial position and the final position is obtained. Now how this can be obtained, that I'll show you. Students, equation of position is given. This is the equation of position, and for this part 2, for which we are going to find this average velocity, for that initial time is this and final time is this. So we can say that this initial time is t1 and this final time is t2. Now in this equation of position, if you will put this time t as initial time, which is 2 seconds, so if you will put this 2 seconds here, then the position will be initial. If you will put this time t as final time, then the position obtained will be final position. So I hope you understood. Let us try. What will happen if we'll put initial time, that is 2 seconds here. Now students, this t is 2 seconds and 2 raised to 2, that is 2 square is 4. So this will be 4. 4 into 2.5 will be 10. Take a calculator and do it. So we'll get this 10, and 10 plus 8.5 will be 18.5. That is initial position x1. It is here. I hope you got it. Similarly, if we will put this time t is equal to 4 seconds here, this time is final time, which is 4 seconds. So now putting 4 in place of t, so 4 square, 4 fours are 16, so this is 16 into 2.5. Now students, what is 16 into 2.5? It will be 40. So 16 into 2.5 is 40, and 40 plus 8.5 is 48.5. That will give you final position, because time is also final, so position is also final. So our answer x2 is 48.5. So I have written this here. Now students, you have values of x1 and x2, you have values of t1 and t2. Simply put these values in this equation, take the difference of these positions, take the difference of time, then solve it. You will get 15 meter per second. I hope you understand this. So always remember students, whenever only single time is given, at that time it will be instantaneous velocity, and when the time is given in this way, from this time to this time, so that is time interval, at that time you will get the average velocity. And whenever we are going to find the instantaneous velocity, and if the position is given, then we have to differentiate position with respect to time, so that we can get the equation of velocity. And after getting the equation of velocity, we have to put whatever the time is given. And for average, we know only this type of difference is taken. Now let us move to our next topic, that is about acceleration. Now students, what is acceleration? That you might be knowing. Whenever velocity changes, we say that the object or a particle is accelerated. Students, when we drive a vehicle, suppose you are driving a car, and if you press the accelerator, then what happens? The velocity of car increases. Even in two-wheelers also, when you move that handle given for accelerator, what happens? The velocity increases. Also, when you apply the brakes, what happens? The velocity decreases. So when the velocity increases or velocity decreases, that can be said as change in velocity. Either increase or decrease, that is considered as change. And that change in velocity with time, because this change of velocity takes some time, and that is called the acceleration. So I hope you understood this. What is acceleration? Change in velocity with time is called acceleration. And so the formula. So acceleration here in terms of average. Average acceleration means symbol is a bar. Here this bar is for average. So average acceleration is change in velocity upon change in time. Now whenever there is a delta, it is some difference, and we can write that difference as final velocity minus initial velocity, as earlier we did for that average velocity. So similarly for here, it is acceleration, delta t, final time minus initial time. So this is for the average acceleration. Now what is for instantaneous acceleration? So students, remember what we did for velocity. We took the time interval very small. Means how much small? that is nearly equal to 0. It is not 0 but nearly equal to 0, that is very small time interval. So we used to take the limit of this term, limit delta t tends to 0. So in that case we'll get the instantaneous acceleration, simply a. If it is a bar, then it is average, and average has delta. And if we'll take time interval very small, then this deltas become dv by dt. Here you can see for average it is delta v by delta t. For instantaneous it is dv upon dt, means very small difference of velocity upon very small difference of time. So this is about the average acceleration, and this is about instantaneous acceleration. Now unit. For unit you have to simply look at these terms. Here in numerator it is velocity. So velocity is in meter per second. And what is time? So time is again in second. So meter upon second square. So we can write the unit of acceleration as meter per second square. Dimensional formula we know only. We did this in second chapter. So now there is no need to explain this dimension, how it is obtained. Now about the graph. Position time graph for acceleration. Xt means it is position time. Graph for acceleration. Now students, we know that whenever there is a straight line in a position time graph, we have studied earlier, if it is a straight line, then velocity is constant, and if something is constant, then its change will be 0. No change, that is constant. So here velocity remains constant. So in that case we can say that the acceleration is 0. But if in a position time graph the graph is curved, it is not a straight line. If it is like this, that is concave up graph, or if it is concave down graph, in that case there is an acceleration, because it is not a straight line. So velocity is not constant for these two graphs, and when the velocity is not constant, we can say that velocity changes, and change in velocity is acceleration, that we have studied in definition only. And so whenever the graph is upward, at that time the acceleration will be positive, and if the graph is downward curve is there, at that time the acceleration is negative. So students, acceleration can be positive, can be negative, and it can be 0 also. Now students, it's movie time. The name of movie is Inception. When I watched this movie one time, I was not able to understand anything in this movie. Only 10% I used to understand. Then I watched this movie second time. Then I understood more in this. Still, many of the things I was not able to understand. Then what I did, I again watched the same movie. Then I was able to understand each and everything in this movie. This movie is based on suspense. So students, I hope what I mean to tell you. Here in 11th standard also, you will find many new concepts. Initially, you will not able to understand it, but if you will go through this video one time, two time, and also if you will go through the textbook, then you will find these concepts easy. Here, this differentiation is new for you. This graphs, position time graph, that might be something new for you, which you will find difficult to understand. But if you will go on practicing, then you will find that these things are quite easy for you. So go on practicing, watch these videos regularly, and then you will find that these things becomes easy for you. So students, it is necessary for you to give time for this type of concepts.